Today we're looking at finding the limit of a function algebraically. How have we done it the past couple days?
Calculator.
Numerically.
Numerically and
Graphically.
graphically. We found limits numerically and graphically. Today we're doing it algebraically. Most people like algebraically a little bit better than the other way. Alright. So here we go. Here's our first one. Read that for me, Blake.
As x is approaching 3.
What'd you say?
I'm not trying to read it.
Bobby, help me out. I'm coming back to you, Blake. You ready?
Remember, x equals 3 of 2x cubed minus 6 over x minus x cubed.
Very good. Very good. The limit as x approaches 3 of 2x cubed minus 6 over x minus x squared. And what is it we're trying to figure out? What y value are we headed towards as we get closer and closer to the x value of 3? Okay? If we are finding the limit of a function algebraically, the number one rule in finding a limit is plug in. So what is it we're going to plug in?
3.
3. So if I plug in 3, 3 cubed is 27. 27 times 2 is 54. Minus 6 on the bottom, that's going to be 3 minus 9. So I end up with 48 over negative 6, which gives me negative 8. And negative 8 is my limit. So what does negative 8 represent?
The y value.
The y value
As
as x approaches 3. So my function is headed towards the y value of negative 8 as we get closer and closer to the x value of 3. So number one rule in finding a limit is plug in. And if you end up with a number, that number is your limit. Now we're going to see here in a little bit that there's two different situations that you might run into besides getting a number. But if you plug in and get a number, then we're good to go. That's my answer. That's my limit. Do another one.
You just plug in the solve.
Plug in and simplify it. And as long as you get a number, you're done. Okay? Sometimes we're going to get something else, which means I need to do another approach, which we'll do here in just a second. All right, next one. Nicholas, read that for me.
Limit of x plus 1 divided by x squared plus 3 as x approaches negative 5.
All right. So the limit as x approaches negative 5 of x plus 1 divided by x squared plus 3. Engage, the number one rule in finding a limit is?
Yeah.
Matthew, number one rule in finding a limit?
Plug it in.
Plug it in. So we're going to plug in negative 5. If I plug in negative 5, it gives me negative 4 on the top. On the bottom, that gives me 25 plus 3, which is 28. So we get negative 1/7 as my limit. So AJ, what does negative 1/7 represent?
The y value.
As
X approaches negative 5.
As x approaches negative 5, we're headed towards the y value of negative 1/7. So far we haven't run into any problems yet. When we plug in, we've got the number.
No problems.
Which means we're about to have a problem.
Next one. All right, Blake, read it for me.
Limit as x approaches negative 8 equals square root of x plus 6.
Oh, the square root of x plus 6.
Okay.
Limit as x approaches negative 8 of the square root of x plus 6. So what do I do?
Plug it in.
Plug in. So if I plug in, I get the square root of negative 8 plus 6. What do I run into?
Negative number or something.
Negative number inside a radical. So what does that tell me?
No. Does not work.
My limit
It does not exist.
does not exist. What is the smallest number I'm allowed to plug into this problem, to this function?
Negative 5. Stop judging me.
She's the closest.
Negative 6. Negative 8. 3.
Less than
Negative 8 was legit.
something less than negative
Negative 4.
Don't keep it.
2.
This is not a tricky question.
Yeah, it is.
Well, after a certain.
-6. Yeah. What?
Negative 6. What happens when I plug in negative 6?
It's just 0.
It's 0. There's nothing wrong with 0. I didn't hear that.
In those episodes.
You just can't have.
Oh.
You just can't have a negative number.
See, you gotta simplify it. You
Hey,
gotta
I don't know if you're one, you know.
girl. I'm glad.
Alright, next one.
I feel offended.
I felt it. I felt your non-judgment.
Limit as x approaches 3 of x minus 5 over x squared minus 9. Limit as x approaches 3 of x minus 5 over x squared minus 9. So again, what do we do?
Plug in.
Plug in. So that gives me negative 2
-2 over 0.
over 0.
So
Goes north.
is it
Undefined.
0?
It does not exist. But what's going on at this x value?
Asymptote.
There is an asymptote. So, how do I know there's an asymptote?
Because it's
When you get a number divided by 0, that is an asymptote. There's an asymptote there. And what is our limit always when we get to an asymptote? It does not exist. Now, I can talk about it later that it either goes to infinity or negative infinity, but we're not worried about that right now. If you run into an asymptote right now, we're just going to say it does not exist and move on. Alright. Limit as x approaches negative 4 of x squared minus x minus 20 divided by x plus 4. Limit as x approaches negative 4 of x squared minus x minus 20 over x plus 4. Number one rule in finding a limit is plug in. So let's see what happens this time. 16 plus 4 minus 20 and negative 4 plus 4. What happens this time? This gives me 0 over 0.
So you have to solve it all the way out.
0 over 0 is called indeterminate. Indeterminate form. If we run into indeterminate form, we're going to be able to find the limit. We just got to go back and do something different. Okay? So indeterminate form is when I get 0 over 0. That tells me I need to go back and change my approach. So I need to go back to my function. Any thoughts on what I can do to this function?
Did you graph it?
I don't need to graph it.
Back.
Factor, yes.
Dang.
Okay, factor. So I can factor that numerator. What does it factor into?
Just kidding.
5 and 4.
5 and 4.
So x minus 5, x plus 4. Okay, and here's a hint. Usually when you factor, this time I was factoring the numerator. When you're factoring the numerator, one of your factors is usually something that's in the denominator. So in this case, when I was factoring x squared minus x minus 20, I had a pretty good idea that one of those factors had to be x plus 4. So keep that in mind when you're doing that. All right, now what can I do? They cancel out. So I have the limit as x approaches negative 4 of x minus 5. And now what do you think I can do?
Plug it in.
Now I can plug it back in. So when I plug in this time, I get negative 9. So my limit is negative 9.
Plug in negative 4. Well, that was.
Okay.
So we start using the number one rule of factoring, or number one rule of finding a limit, which is plug in. That gave me 0 over 0, which told me I needed to do something else. In this case, I needed a factor. I canceled. As soon as I canceled, then what did I do again?
Plug it in.
I plugged back in. So what does negative 9 represent?
Y value of x approaches.
the y value of this function as x approaches negative 4. Now, what is going on at negative 4?
It's,
What is at negative 4? There is a hole. That is correct. How do I know there's a hole?
Because there's just something at the top and the bottom.
Whenever you cancel something out like this, that means you're dealing with a hole. Whatever makes that 0 is a hole. So there is a hole at negative 4. That's why I'm allowed to have a limit. Because there's a hole there, but I can still go to the same spot from both sides. All right, so first thing you do, our first strategy when you run into indeterminate form is factor and cancel. Next one, the limit as x approaches 9 of the square root of x minus 3 over x minus 9. So I want to find this limit. So what do we do to get started when we're finding a limit algebraically? Plug it in. What happens when I plug in?
Zero on the bottom.
I get 0 over 0, which is indeterminate form, which means I need to do something to find my limit. So what do you suggest we do on this one?
Factor the bottom.
Factor the bottom?
Yeah.
All right, you can do that, but nobody else is going to be able to see that, Nick.
Why not?
But yes, there's nothing wrong with it.
I mean, you can.
Right, I agree. That's what I said. You're fine with that. But everybody else in here is going to be easy. It's going to have an easier time seeing the other method. What's the other method? Not square it. What do we do when we have a binomial and it has a radical in it?
Set it equal to 0.
By the, starts with a C, conjugate. We want to multiply by the conjugate when we have a binomial that has a radical in it. So, we want to multiply by the square root of x plus 3. So that gives me x minus 9 in the top. On the bottom, I leave it as x minus 9, the square root of x plus 3. You do not multiply it out unless you're multiplying conjugates together. So that's why I multiplied out the numerator, but I did not multiply out the denominator. Okay? So you only multiply it out if you're multiplying conjugates together. And now what do we see happens?
Cancel out.
I can cancel out. So I have the limit. And here's what a lot of people are going to do to me. There should be a 1 in the numerator, but a lot of you, I guarantee you, are going to drop that and just say it's square root of x plus 3. And what do we do immediately after we cancel? Plug it in. So now I plug 9 in, so I'm going to get 1 over 6. So what is 1/6? The y value of this function as x approaches 9. That is correct. Now here's what Nicholas likes to do. He likes to factor this bottom as the square root of x minus 3 times the square root of x plus 3. And then he would cancel this out, which gives me 1 over the square root of x plus 3. And you end up with 1/6 as well. So there's an alternative approach. So figure out which one of those you like, stick with it.
No?
Yeah, because this is good price.
Next one. I have the limit as x approaches 0 of x over 2 minus the square root of x plus 4. Limit as x approaches 0 of x over 2 minus the square root of x plus 4. What's the first thing I should do when I am trying to find a limit algebraically? Plug in. What do I get in the numerator? 0. What do I get in the denominator? 0.
2 minus 4.
Because I get 2 minus the square root of 4, which is 2 minus 2, which is 0. So I get 0 over 0. So what do you suggest we do next?
You have to go back and do that. Although does that work? That. No, but when it starts with an I, well, we know it's that.
It's indeterminate form.
Yeah.
So what do I do now?
So,
Multiply by the conjugate. That is correct. So what is my conjugate?
What did you say?
It's 2 plus.
Yeah.
So I get the limit as x approaches 0. I'm not multiplying the numerator out. Why not?
Because it's 0.
Why am I not multiplying the numerator out?
Because 0,
Because it's not conjugate.
It's not conjugates. You only multiply it out if you're multiplying conjugates together. Which I am in the denominator, so that makes it 4 minus, and a lot of people will do this. And, oh, yep, sorry. A lot of people will do that to me. What did I have? How did I mess up? Well, I got a square root times a square root, which just eliminates the square root, which gives me the x plus 4. I'm still wrong. Why am I wrong?
You need to keep it so you can cancel from the top.
What did I do wrong? I'm very close. I'm just slightly off. And I made a mistake that you guys will make.
Should the square root still be there?
No,
somewhere?
because I got a square root times a square root, which means I'm going to end up with the inside.
Do you need a factor of the negative?
What do you mean
Before?
factor? You're not saying factor is the wrong word.
Distribute?
Distribute. Okay, this negative has to be distributed to both of those. And you guys won't do that. You guys will forget to distribute that. Okay? So if I distribute it, I have x times 2 plus the square root of x plus 4 over, if I distribute, I end up with just negative x in the denominator because those 4's cancel. Okay? And I would have had a dead giveaway that I did something incorrectly because I would have ended up with negative x plus 16 on the bottom. And what is the dead giveaway that I did something wrong? Because what should I be able to do at this point? I should be able to cancel. If it was 16 minus x, I don't have anything to cancel, which tells me I did something wrong. Okay, whenever you multiply by the conjugate or whenever you factor, you should have something that can cancel. If you don't, then that means you made a mistake somewhere. So now I can cancel the x's. I have 2 plus the square root of x plus 4 in the numerator, and I have negative 1 in the denominator.
Just make that a negative 2 plus.
If you distribute the negative, you can. And make it a negative 2 minus the square root of x plus 4. Alright, at this point, what do? Plug in. So I plug in 0 in the numerator. So what am I going to get in the numerator? 4. So it's going to end up being negative 4. Reagan, what is negative 4? What's negative 4 represent?
The limit as x.
Okay, give me something besides the limit. What does it represent besides the limit? What do we say a limit is? What is the limit? The y value. So negative 4 is the y value that this function is headed towards as I get closer and closer to 0. Alright, so number 1 rule in finding a limit.
Plug in.
Plug in. If I get a number, that's my limit. I'm good to go. If I get a number over 0,
It does not exist.
does not exist. If I get 0 over 0,
And you need to go do something more.
it's an indeterminate form, and I have 2 strategies so far. What are my 2 strategies? Factor and cancel, or multiply by the conjugate and cancel. As soon as you cancel, what should you do?
Plug back in.
Plug it back in to get your limit. Very good.